want the total resistance. So I have to so I'm going to shrink this 4 ohms. When I shrink it, this, so it looks like this. That's still 4, 4. This becomes 2, 4, 4, 4, and 2. And now I can do this. 6, 6, 8, 4. I can do this. 8, 4, 3, and then finally the last one. 15 ohms total resistance. Then 1B. The question is, which would be the bulb? What? You have got to be kidding me. So I'm supposed to say rightist. So from that, we have to figure out since all the R's are constant. Oh, let me do this. So for this, we know that this current and this current are all the same, and we know that this current, let's call this IA, call this IB, those two are the same, and we know that IA over 2, IB over 2, IB over 2, IB over 2, those are the same, because it has to get split because they're all 4 ohms. So if I use P equals I squared R, then wherever I is the biggest, that's where we're going to have the biggest current. And we know that IA, actually we know IA is equal to IB. And so therefore I is equal to IA plus IB. That's just the junction rule. So we see I over 2 is equal to IA. So this actually just becomes IA. I called it IA just to let it know. So then that gets split in half. So then that gives us the full relationship. So clearly, the order of brightness, if I below the brightest, this one and this one, brightest, second brightest, third. Second brightest would be here and here, and third brightest, of course, would be those. 1C, with the current and the voltage in each resistor. Okay, so if this volts, we remember that the total resistance was 15 ohms, so this is 2 amps. 2 amps. White, 2 amps, 2 amps. And remember what we said. We said that this was half of that, so that means this is 1 amp. This is 1 amp, and these are half. So this is a half amp, half amp, half amp, half amp. Okay, and then so back to all of these are 4 ohms. 8 volts. This is 4 volts, 2 volts, 2 volts, 4 volts, 2 volts, 2 volts. And of course, that's it. So we know all 3 things. And D, how much power is consumed in each resistor. So use whatever you want. let me just get here, and I'm just going to use E equals, let's do IV. So IV is 16 amps, 16 amps, 16 amps. IV is going to be 1 amp, 1 amp, 4 amps, 4 amps, 4 amps. Oops, just IV should give me, oh jeez. Sorry, these are all watts. Sorry, the numbers are watts. Watts, 16 watts. IV is 4 watts, 4 watts. This is 1 watt, 1 watt, 1 watt, 1 watt. And if you add all these together, sum of the power, then you can use this to find out the energy used. That's a hint. So if you want to know the energy used by the total circuit, you can find that. Next, we go to the second one. So 2A looks like this. Okay. So the capacitances are 70 microfarads. So then now we go through and condense. So remember, what's in series is inverted. What's in parallel is normal. So from this, I do this. That's going to be 70 still. That's going to be 70. Wow, that looks good too. That's going to be 70. This is going to be 140. Okay, now I go to this. 70. 70. That becomes 210. And now I have to do 1 over 70 plus 1 over 210 plus 1 over 70 plus 1 over R. So this looks like 3 over 210, 3 over 210 is 6. It looks like it's going to be 7 over 210 plus 1 over R. And then I think it's going to be 1 over 30. So we're going to get R. What a genius. It's supposed to be capacitance. Gosh. So we're going to get C is equal to 30 microfarads. So if we come down to this,